Hi everyone, my name is Shijie Cao. I am security researcher at Tencent Security Lab and a security architecture for the Group International Mobile Application.
Hi, I'm Zhao Hao, a security researcher and the head of Tencent Security Lab of Group.
The RPC protocol is called Remote Produce Core, and currently such a protocol has been applied to a large number of Internet mobile application and IoT device. The advantage of the protocol is that the CS mode communication process. The application only needs to know the name of the remote service and the input parameter for accessing the remote service to obtain the resource of the server. For developer, this calling process doesn't need to pay attention to issues such as IP port path, just like accessing a local API interface. The gRPC feature. gRPC is a highly valuable network communication framework provided by Google, which allows application to call service interface like local interface. In the gRPC protocol that uses the HTTP2 version, the network stream is directly transmitted through the TCP protocol, which reduces the network overhead of the continuous TCP handshake in HTTP and make the network transmission faster. In gRPC application, usually use protobuf serialized data format. This has the advantage of being able to compress network data during transmission and flexible update the date format in the network data. Because of the attribute, this makes the analysis of security personnel no longer as simple as in the past. Undoubtedly, this increased the cost attack on application network interface, but it is not undestructible. In this briefing, we propose a method that can automatically exploit the vulnerability in the server interface for application that use the gRPC protocol. In the past period of time, through reverse analysis, we have developed a set of vulnerability mining methods can be almost full automated for mobile application and IoT device. According to study, dozens of security vulnerabilities can be found almost every month. From the developer perspective, it is believed that the application itself will carry out various security protection measures, so that the network request in it from the client is incredible. However, from the perspective of an attacker, various mechanisms on the client side can bypass the local security logic through reverse engineer and the hook method, thereby fake reasonable requests to attack the server side. As description in Game of Thrones, people think that the great war can withstand the ghost, but they did not expect to be destroyed by the ice dragon. If you need to conduct automatic vulnerability mining on the application of the gRPC protocol on a large scale, on the one hand, you need to be able to bypass the security mechanism on the mobile application. There is a certain amount of reverse engineer job and developer inject code to bypass the application logic. On the other hand, we need a large number of data set to analyze which valid data is our focus. Finally, we need to build our own arsenal for different data features, implement payload for testing remote gRPC service. We use IDA Python to analyze the core relationship of gRPC in the binary. It should be noted that because we use the recursive method to query through the relation function of IDA Python, we need to constantly check whether there will be error, such as judging uncertain whether the method is actually called by the function corresponding to a certain class name. Otherwise, there may be more false positive. Therefore, we set a state for each level of core. When entering a level of our relationship, a push state will be recorded in deep. When a core chain is passed, we will use the pop state to perform a level. Layer backtrace until it returns to the root node and then processed to the next core chain analyze. In this way, when we look up to the core chain with several gRPC functions, we can find that different core chains exist at the leaf node, which may come from the same class or the same method, so as to obtain the encapture gRPC protocol method. We need to recognize gRPC logic and intercepting intercepting gRPC request. The step 1 is through IDA Python, we can quickly help us to locate the network library that encaptures gRPC. And in this time, we need to develop a generate dynamic library model to intercept to execution of gRPC. The step 2 is obtain the gRPC method name, original protobuf date, and a header field and extension field corresponding to gRPC through the gRPC encapture function of the hook network library. Need attention to some of application. An independent security model is added for some security protection. In order to complete the gRPC date replayability, we need to build a reasonable signature and hide the memory model. For the structure of the signature, we usually call it through reflection invoke method. The content of the date part is passed to the API interface of the corresponding model to obtain a valid signature. To prevent environment security detection, we usually hook in some memory function. When the name of the enumerated memory model is equal to the name of the model we injected, we will return the name of our system model. As shown in the figure, we enumerate a model on the else side that filters the self-model name through the method of .getImageNames function. The replayability construction, in order for us to schedule different applications to reply gRPC requests more easily in the last stage, we need to build a gateway on a server and let different devices register the gateway. On the client, there will be a heartbeat communication model that tells the gateway its own device model, device ID, and some basic information about the application, and the server will store this information. At the same time, we provide a set of Python script to provide a fuzzing program that can schedule remote machine in real time for gRPC real-time network request and communication, and get the response date. Another point to note is that the order to make the replayability relatively stable, we have added a daemon process to protect and monitor the application of the reply device. On the Android side, we use the ADB command to monitor whether the process is terminated, and if it is terminated, it will be reawakened. For iOS, we will register a daemon process to notify the process through notification center get_derived notify center method. When the process is about to die, we will notify the daemon through a message to tell the process to restart. It is conceivable that different device and application will have the function of amount linking. If the device is not linking in, there will be access failure during gRPC request replay. For Kubernetes, because the linking process is also implemented with the gRPC protocol, we can simulate the gRPC method of the linking request with the pre-made test account, and then open a temporary linking session.
Okay, I will introduce the data acquisition, paths, and analysis. First of all, we need to get a sufficient amount of gRPC traffic with a large coverage rate. If you plan to test your own application, you can get desynthesized gRPC traffic at the traffic hub and gateway. If you plan to test third-party applications, you can obtain the gRPC traffic data by hooking the target client. If the data you get is in protobuf if the data you get is in protobuf format, the key in the original data key-value pair will be removed. Even if we don't have the original PB class, we can still get the value information through the reverse analysis method and mock the value information to form a new usable protobuf format data. And you can get such tools in the open source community. For the large amount of gRPC traffic data we have obtained, we have adopted a variety of methods to conduct sampling to reduce our test work without losing the information as possible. Sampling methods include the random hash sampling, cluster sampling, and so on. In the cluster sampling, we sample based on the interface ID of each gRPC. The sampling to each ID is kept basically the same, thereby reduce the influence of the frequency of gRPC interface in the test result. At the same time, we filter a large number of gRPC interface IDs that do not have private attributes based on the entropy value. We believe that such a gRPC interface will not have unauthorized vulnerabilities. This saves us a lot of work.
My colleague mentioned about the privacy of the gRPC calculation method. We will obtain a private gRPC interface through the result of data analysis. It can be found that it is rate close to 1, then nearly the private and easy to content the sensitive information. If its rate code close to 0, they are near the public, and the content may be some server-side public configuration. Through the sample of data of this interface, analyze whether sensitive parameters are included in the response. the ruler can be analyzed through regular expression. If there is sensitive information, it will follow into the next process. Analyze the validity of the date. For example, if the result of the request is only some invalid content, such as the date and some public ID, it may not be of much value. Of course, we will also maintain a global whitelist for subsequent false positive, which are continuous add to the whitelist for filtering to prevent second false positive. If all of above conditions are met, it's beginning to test current gRPC request. First, we will use the reply ability to obtain a valid login state for the test account. Second, we need to replace the login state in gRPC date by our test account. Finally, send the constructor date package to our corresponding gRPC replay gateway to obtain the response of the test gRPC package. After obtaining the response, we will perform simulated analysis on the response and filter invalid parameter to determine whether it will eventually follow into manual verification. If the obtained result is too different from the original, the current gRPC method follows into the whitelist mentioned above for filtering. We will get a better case for logic bypass vulnerability. This is a real case. As an example below, in this request, we can see that gRPC server allowed to accept any license plate number and phone number, so that when we fill in the correct date, we can see other people's information and can be modified. The reasons for this vulnerable is that the server doesn't verify whether the current user login state has access to and modified the corresponding business state, which leads to the risk of logical authority bypass. The idea of SSRF vulnerable on the gRPC server is mainly divided into the following steps. The first, we need to build a web server that can receive notification. When attack success, the line server will to request our target server that we can be notified the real time. Next, we need to analyze the value in each gRPC request to determine whether field is like HTTP. If it exists, traverse each values containing HTTPS string and replace it with the domain name or IP corresponding to our web server. And then you only need to wait for the web server to receive notification after replay. Let's take a look at this case. The request is obtain a field name resource URL. The corresponding content is like CDN resource, and we guess that this picture is probably obtained by a server through a HTTP GET request. So we replaced the resource URL with our web server, and finally, our web server actually received a request from an IP, and the requested URL content the gRPC method we deliberately added. From the core chain in the figure, we find that from the real attack chain, the resource URL is actually passed through multi-servers, so it is also the difficult faced by the enterprise. When an attack payload request arrive at the server, any server node may become the target of attack. In the following explanation, I will introduce some other effective exploit idea. The first, I will introduce a cycle injection vulnerable discovered in our historical situation. In view of the cycle injection vulnerable, our thinking is that since most of the gRPC data requests are in JSON format, we will analyze which field exist, query or modification type, and whether there are sensitive information. There are two main reasons for this. On the one hand, there are certain parameters that the server may not query in the database, such as the time, URL, and other information. Uncertainty, like some meaningful field, it may enter the query in the business logic or in the modified cycle statement. The reason why you need to match sensitive information is because of some special parameters, such as email, phone number, and other information. When the condition for cycle injection are met, the meaning of the obtained data table is more valuable. After our actual test, we conduct a small-scale test on 10 of thousands of gRPC interfaces and found a cycle injection vulnerability in one of the gRPC interfaces. As you can see from the figure, when they performed cycle injection testing on the UID date, the server returned the reason for the error, which also proved that this location is the process of executing the cycle. The next case is an interesting vulnerable in history. The cause of is a zip file that can be downloaded remote in the URL. When found this request, try to replace it and with a zip file with a director crossing vulnerability on the CDN. And replace this link into the gRPC request. Finally, the server downloads the file and tries to decompress it, and the file covered the original bashrc file, which caused the Linux system to execute the shell command in the file. The last case is remote vulnerability caused by the log server. At that time, we found a string with type string in a request, and we guessed that the local date might be deserialized by the server. Therefore, we implant a fast JSON remote command execution payload in the request, and we wait from a day to night. When we overthrow it might not be successful. We received the corresponding result confirming the success of the executing. And later, we contact the manufacturer of understanding the situation because was not the server we attacked that finally triggered the security vulnerability, but because the server stores the data to the log server, and this log will pass by another server. During the analyze process, fast JSON deserialized is used executing the string with deserialized vulnerable in the parameter. Okay, I believe everyone is already very interested in the actual demo. Since our platform involves different components, I have prepared a real demo to explain to you how we do gRPC network replay, data analyze, and how to counter the vulnerability. I hope you will understand more after watching it.
Next, I will introduce several security defense methods for applications based on the gRPC protocol. The first introduction is the WAF system based on the gRPC protocol, which can quickly intercept most of known attack payloads based on the configuration. Then there is the cookie isolation. We can set cookie isolation under different applications to ensure that a single point of attack cannot affect all applications. Next is the AOS defense system. AOS aspect of security is a security defense system proposed by the security department of our anti-group based on the aspect thinking. It achieves the decoupling of security and business logic and realizes the integration of security into business logic for comprehensive security protection. In addition, automated upgrades to the third-party SDK of the supply chain and the unified security authentication for different application systems can also help build a more secure application system behind the gRPC protocol. Okay, let's have a summary. First, in the era of mobile internet, a large number of services rely on the gRPC protocol for data exchange. There is a huge attack surface in the middle. Secondly, with the rapid development of the internet, the gRPC protocol has become the basics of network protocol facilities, need support defense facilities to avoid external network security risks. That's all, thank you.